Welcome to Field Lab Earth, the podcast that's all about past and present advances in the fields of agronomic, crop, soil, and environmental sciences. Today, we'll be talking to Dr. Sharon Schneider. Soil erosion is a serious problem that can have a huge impact on crop production. Preventing it in the first place is a key strategy, but what can farmers do with land that's already been severely eroded? In this episode, Sharon joins me to discuss her research on a more manual, earth-moving approach. We'll talk more about that in a minute, but before we dive in, we want to thank our sponsor for this episode, EA Consumables. EA Consumables is the exclusive U.S. distributor of organic elemental analysis products by UK laboratory supplies manufacturer Elemental Microanalysis. Visit eaconsumables.com for high-quality elemental analysis consumable supplies that offer performance you can trust. I'm your host, Abby Morrison. Let's talk about science. Hi everyone, welcome to the show. Today we have Sharon Schneider with us. Sharon has spent her whole professional career with the USDA Agricultural Research Service, currently serving as research leader of the North Central Agricultural Research Laboratory in Brookings, South Dakota. She previously served as a research soil scientist in Riverside, California and Morris, Minnesota. Her research program has addressed soil processes that affect the fate and transport of organic compounds and crop productivity. Welcome to the show, Sharon. How are you?
Thank you. Doing well.
Good. We are so happy to have you on the show today. So we are talking about erosion and addressing that problem. So can you just on a high level kind of go over the problem that your research was hoping to address?
Sure. Soil erosion is a major factor that limits crop productivity, and it's a worldwide problem. Land degradation by soil erosion is expected to result in about $44 billion in loss in the United States alone, and similar losses occur throughout the whole world. A lot of that loss is due to decreased crop productivity in eroded soils. And so we were looking at ways to try to restore the productivity of eroded soils without compromising the productivity of good soils that are already there. An intuitive way that we were looking at was to reverse the soil erosion process. So soil erosion removes soil from, in general, upper landscape positions that are convex in shape, and soil is accumulated by erosion in areas of decreasing slope or in concavities. So what tends to happen in hilly landscapes that are subject to long-term cultivation is you have a general loss of topsoil in upper convex landscape positions and accumulation of topsoil in lower concave landscape positions. And we were looking at what would happen if you would just physically restore the landscape to the way it was before all that soil got moved. So actually physically moving soil from areas where it accumulates to areas from which it was lost by using earth-moving equipment to put it back in place. And so then we were cooperating with a couple farmers who were interested in that approach, and we conducted a multi-year study at 2 locations to look at the influence of that practice on soil properties and on crop productivity.
Sure. Yeah, I was really excited by this research because it just seems like such a simple solution. So I just was really attracted to that idea. So there were kind of 4 areas within this research that you were kind of trying to specifically look into as far as the effectiveness of this process. So can you tell us more about that?
So we wanted to know what conditions would make this approach work well. So what kind of landscape characteristics would respond well to this approach, how much it might cost and what kind of return you might get from restoring the productivity, how long that increase in productivity might last, and what soil properties were most at play in the yield responses that we saw. So those are the 4 main things that we were looking at.
So you were looking at these 4 different areas about where it would work and how long it would work and all the costs and different things that would be advanced or not by this process. And like you mentioned, you had a couple of different sites that you were looking at. So I would love to hear a little bit more about kind of the differences between these sites, how you connected to them, and how you intended to test the different sites.
Yeah, we had 2 different sites. One was in west central Minnesota. It was a severely eroded landscape. The farmer that we cooperated with joked that this is the glaciers were not kind to me here. And adding on to the glaciation aspects of creating the landform in the first place, 100 years of soil erosion through intensive cultivation, through crop production at that site, resulted in almost total loss of topsoil in the most eroded landscape positions. Our Minnesota site was a relatively uniform ridge that extended from the crest of the landscape down into a depression. And there we saw, like I was saying, almost total removal of the high organic matter material from the top of the slope. So we had subsoil incorporated into the tilled horizon of that landscape in those landscape positions. At the bottom of the slope, where erosion accumulates topsoil, we had 2 or 3 up to 4 feet of high organic matter material in those landscape positions that was brought in by erosion. So the original landscape had about 2 feet of high organic matter material in those landscape positions, and then everything on top of that, which was a foot or more, was brought in by erosion. So that was the condition in the bottom slope, deep accumulation of topsoil. In the upper landscape positions, we had subsoil incorporated, like I was saying, into the tilled horizon. And so since that subsoil is high in calcium carbonate, it's really light in color. And so visually, this landscape was quite striking, where the top of the slope is tan, and in a field that's otherwise pretty much black because of that incorporation of subsoil into the tilled horizon. So that was what our landscape looked like in Minnesota. Then we had a second site in northeastern South Dakota, in Roberts County, South Dakota, and that site was much more moderate in all ways compared to the severe erosion at the Minnesota site. The hills weren't as steep. They didn't have as much difference in elevation, and they didn't have as much difference in slope gradient as we saw in Minnesota. And so the extent of erosion was lower. The difference in soil properties was lower. The difference in crop productivity across that landscape was just much less severe than what we saw in Minnesota. So at the Minnesota site, the crop yields where it was most eroded were about half of what they were in the highest yielding portions of the landscape. In South Dakota, much smaller differences.
Sure. So I know I asked you what you were testing, but I'm going to stop here to just kind of do a 101 with me on some of these things. So the topsoil in the Minnesota site that was being stripped away and revealing this subsoil, that was getting like tilled in. You mentioned a horizon, so that's just a soil layer. So I'm just
Correct.
You're nodding at me, so that's good. Just so people, if you're not familiar with that, so why is it like a big problem to be dealing with the subsoil rather than the topsoil? I know that like the soil organic matter is helpful for the plants. Is it that? Is it there's like living critters in the top that are not in the bottom? Is it a nutrients thing? Like what's going on with the subsoil?
All of the above. Yes. So soil organic matter is critical to plant growth. It also influences a lot of other soil properties. So soils that are high in organic matter generally have higher nutrient availability. They have higher water infiltration. They have higher water holding capacity, and they support a higher population and higher activity of soil microorganisms. So when we were evaluating soil properties, we were looking at the physical properties, things that affect movement of water and heat in the soil. We were looking at chemical properties, beginning with organic carbon, because that's a really keystone property, but then also plant nutrients, the nutrients that plants need, like nitrogen, phosphorus, potassium, and then soil biological properties. But there we only touch the tip of the iceberg, because there's so much that's being done right now in soil biology. And we were only looking at a very limited set of biological properties. But soil organic matter is really critical to support plant life, and subsoil really doesn't have most of those things. You can fertilize it, but it just doesn't support plant life the same way that high organic matter soil does.
Sure. So then, additional question. I feel like me, as a non-scientist, my natural thing would be like, well, wouldn't eventually subsoil just turn into topsoil, or vice versa at the bottom? So is that... But I also feel like that would just take a really long time. So
you are right.
Okay. Yeah, so can you tell me more about that?
You are right. The soil formation process is very slow. And so as plant material and other living material decomposes, it does form, some of it gets formed into soil, but this takes centuries. And we're really looking at something to do something a little faster.
Sure. Fair game. Cool. Okay. I just wanted to pause there and kind of lay a little bit of foundation, both for people who are not soil scientists and also for me, who is not a soil scientist either.
Yeah.
So then you were testing this method on both of these sites. So I'm curious how you did that, both in general and also just at these different depths that you were trying to get, how to do it without just completely compacting everything and killing all of the little critters that lived inside. Tell me all about that process.
The actual process of moving soil was quite fascinating to me. Both of the farmers that we collaborated with had earth-moving equipment, the kind of stuff that you see on a construction site. And so they used these scrapers to remove soil from the areas that we had staked out. So before we invited them in to start driving their scrapers around the site, we flagged out, we want you to remove soil from here and add it here, based on some initial soil samples that we took. So at the Minnesota site, for example, we laid out the plots side by side, and the plots extended from the crest, from the very top of the hill down into the depression. We stopped just short of the depression, so people who are into landscape terrain, we went from the crest to the toe slope. We removed soil from the foot slope and the toe slope and added that soil to the same depth in the crest, shoulder, and upper back slope of the same plot. So we removed 6 inches of soil from the lower slope and added 6 inches of soil to the upper slope. He did that in multiple passes and tried to get a pretty uniform distribution of soil where we wanted it added. And then at the end of all of that, he chisel plowed the whole site to incorporate that soil into soil that was already there, right? So you didn't have this sharp demarcation of loose soil versus consolidated soil. So that was the Minnesota site, six plots laid out side by side. At the South Dakota site, totally different situation where we had just a series of low hills. And there, that farmer used his scraper and kind of snaked along the base of each of these low hills and set his scraper depth to about 2 inches. And then he applied that soil to only 1/2 of each hilltop. So half of the hilltop had soil added and half of the hilltop had no soil added. Then, because we also wanted to know what would happen where you removed soil in a larger area, we had him remove soil from a designated spot, but that wasn't, the bulk of the soil was from him snaking around the base of the hills. So both sites, we had side-by-side comparisons of where we added soil and where we didn't add soil, and where we removed soil and where no soil was removed.
Hi everyone, I hope you're enjoying the show. Interested in learning more? Sharon's papers, Key Soil Properties and Their Relationships with Crop Yields as Affected by Soil Landscape Rehabilitation, and Crop Responses to Topsoil Replacement Within Eroded Landscapes, both published in Agronomy Journal, are always freely available. If you are a certified crop advisor or certified professional soil scientist, you can take a quiz for continuing education units for this episode, which can be found in our show notes or on certifiedcropadvisor.org. Thanks again also to our sponsor, EA Consumables. What kind of soil standards does your lab need? Loamy, clay, peaty, chalky, silty? EA Consumables has a new line of synthetic soil standards from Elemental Microanalysis, which offer superior consistency between batches for improved analysis results. These synthetic soil standards are made from pure mineral and chemical ingredients. Visit eaconsumables.com for more information. Thank you for being our sponsor. Let's get back to the show. I love that. I think that just sounds so fun. There's like definitely the playground kid in me who just wants to be moving all the sand around the sandbox. Not necessarily sand as in like the soil, sandy soil. Just being clear. I'm not trying to imply anything there. So yeah. Oh man, I'm just so excited because I think this is such fun research. So what did you find? What were your results?
We found that especially at the Minnesota site that was so very eroded, adding topsoil increased grain yields by quite a large margin. That crop system was in a corn-soybean rotation. At South Dakota, it was in a soybean wheat rotation. And thanks for pointing this out, that the farmer farmed both sites as part of the larger field. So he, fertilized it the same as the rest of the field and used the same weed management and all of that. So we weren't precision farming our landscape, our experimental site. So with the same amount of input at the Minnesota site, grain yields were increased by 21 to 53% for corn and by 12 to 59% for soybean. So we achieved that with no additional seed, no additional fertilizer, no additional weed management, or what have you. So that was a pretty good return for us. At the South Dakota site, we didn't see any statistically significant increase in yield. The yields were numerically higher, but they weren't consistently higher, and just really that was a less convincing situation at that moderately eroded site. So in Minnesota, going back to the Minnesota site, where we added soil, because it was so eroded, where we added soil, we increased the soil organic carbon concentration by 2 to 3 times higher than what it was when, in its eroded condition. So putting all that good soil back up there really did its job, and the crop yields then were pretty consistent from the top of the hill to the bottom of the hill, probably similar to what they were back 100 years ago. In terms of consistency, where the productivity isn't so hugely different between the top of the hill and the bottom of the hill. When we looked at the economics of that, we just used the crop price at the elevator the day that we harvested the grain. So those increase in yields, we pretty much recouped the cost of doing the soil movement within the first 7 years of doing that soil landscape rehabilitation. So that's a pretty good payback time. And that's including the cost of owning and operating the equipment. And again, basing that on the increase in grain yields under the same conditions as what the farmer was using to farm the rest of his field.
Sure. I have a few questions about about that economics. So is this something where the farmer kind of does this, kind of a one and done deal? Is this something that they continually have to come back? I mean, you said these people kind of already owned that equipment. So are you adding costs just because of obviously the labor time costs something and, fuel for the machinery and things like that?
Right. Those are the two main things.
So I guess I'm just curious, like, where that breakdown comes from and what maintenance looks like for these fields after you've moved the earth on them.
Yeah, the cost of doing the restoration was estimated by the time that it took the person to do the earth moving, and based on standard economic principles. So we expect that this is a long-term solution. Part of our question was, how long will these increase, if we see increases in crop yields, how long might they last? Well, the first phase of this study was 6 years, and the crop yields are still going strong at 6 years. We actually did some follow-on studies, and they were still going strong at 10 years after. So I think it's a pretty robust solution time-wise. Keeping in mind that the legacy of soil erosion at the Minnesota site and at the South Dakota site were both on the basis of the whole time since the Western settlers arrived until now. This is more than 100 years of cultivated history, and most of that time they were doing pretty aggressive cultivation with a mower plow, plus multiple tillage operations during the year for weed control. So it was pretty aggressively tilled for a very long time. Now our technology uses much less invasive tillage. We expect the rates of soil erosion are probably much lower than they were historically. So hopefully keeping that soil where we put it, that's an important part of this practice, is you want to reduce your tillage and increase your conservation so that you only do have to do this once in a lifetime.
Yeah, that's good to know, because I was wondering about this of, is it something where it's like, okay, you make your money back, but then you have to do it every 7 years. So you kind of are just in a cycle, or is it every 2 years you have to do it? So that's great to know that it's not like this commonly recurring cost. And then I was also curious about kind of maintenance from now on, of like what farmers can do to stop this from happening. It sounds like just in general, that's a lot less of an issue than it would have been in the past. So that is also hugely encouraging. But are there, general tips or practices that you would encourage to kind of maintain that? Or is that just kind of general erosion practices you would use anywhere?
Sure. Well, and soil erosion is still a problem, and it still happens. You cannot avoid it. Every time you do an operation in the field, even seeding or anything like that, soil is lifted. And every time the soil is lifted, gravity moves more of it downhill than uphill. Actually, some of the modern agricultural operations are as erosive as some of the more historic ones, because we're going faster, and we're sometimes just the design and operation of the implement makes it move a lot of soil. So soil erosion is still going on. Don't get me wrong. However, rates are generally lower, I think, than they were in the past. So in general, I recommend conservation practices like reduced tillage, cover crops, things that keep the soil in place, so that once you make that investment of moving the soil, it will stay there and do its work for you. Now, coupled with that, I would say that our experience with the Minnesota site versus the South Dakota site indicates that this practice is really for the most severely eroded land that you have. This isn't a practice that you would probably do on all of your acres. It would be reserved for your most eroded acres. There are things that might make it cheaper for you to do a soil landscape rehabilitation operation. Things like reducing the distance between where you're getting the soil and where you're putting the soil. I mean, that might not be up to you, but in certain situations, there might be things that you can do. Like if you're cleaning out a drainage way anyway, instead of just dumping the soil nearby, you could spend the extra however many hundreds of feet to move it where it might do you the most good. So there might be things that you could do where you're moving soil around the landscape anyway. Putting it where it might do the most good could be a good payback for you. But keeping in mind that you're going to see the best payback where the erosion is the highest, soil loss by erosion is the highest.
Sure. Yeah, that's great advice as far as taking care of the land. So one of the things that you mentioned in your worksheet was kind of how this is a pretty intensive treatment for the land. So I was hoping you could just speak to that a little bit. I mean, obviously, it's not something that needs to happen for every field, which is great, but it would be nice to not have to do it on any field. So can you just talk about some of the implications you found and advice you had out of that?
Yeah. So you're right. Some people have said, well, that's pretty aggressive. That's like a sledgehammer approach. And it is, actually. It is a pretty aggressive means to restore productivity. There's been a lot of work in the past decades on kinder and gentler approaches, perhaps like using cover crops or reducing tillage. Those are some of the things that I talked about. Those work really well where the landscape is already functioning well. They build organic matter and they improve soil health. In these situations, the analogy I sometimes like to use is this might be similar to a healthy diet and exercise for us. Cover crops and reduced tillage and conservation practices like that are a healthy diet and exercise for the soil. However, some people with heart disease need stents put in before they can have a healthy blood flow to their heart to enable them to have to participate in exercise, for example. And so I liken this soil landscape rehabilitation approach to installing stents in somebody's heart. You have to like jumpstart the system in some cases, or it might be beneficial to jumpstart the system in some cases so that you can increase what's called primary productivity, which is the amount of organic material that you're adding to the soil and incorporating into the soil through plant roots and plant biomass. Generally, the more plant material you can grow on the land, the higher your organic matter inputs are, and the more that is incorporated into soil. So to build organic matter, you need plant production. You can't produce plants very well in really impaired soil. So this is a way of like I said, jump-starting the system so that it can produce plants, so that it can build soil in less than a couple centuries. And then you can implement alongside that a healthy diet and exercise of other conservation practices and just keep things in a nice, healthy state.
Yeah. Yeah, I really like that because I feel like it ties back into some of the things that we were talking about earlier of like how it just takes forever to get the soil to recover on its own. We've talked about that on the show before of why it's really important to take care of what we have because it's a lot easier to take care of it than to need to get the stent later.
To build it. Yeah.
So I feel like that ties a really nice bow on a lot of this conversation, and yet there's still more to be discovered. I feel like there's been a lot of just natural questions of what next and what else to test that have come out of this. But what are some things that you see on the future soil horizon of this research? Where are we going?
Well, for us specifically, once we finished a 6-year study, we used that same Minnesota site as an add-on study where we compared what would happen if we would use a soil amendment instead of soil to improve productivity? Would it have the same effect? We were at that time collaborating with a dairy farmer who had a methane digester in his operation. These are quite common now. And so we used the solids from that methane digester as a soil amendment and compared that to what kind of yield response did we get with the soil. So in that case, we split the plots in half, and then we had 4 treatments. We had places where it was left in its eroded condition, so nothing had been added at all, where we had added soil back at the beginning of this phase of the study, where we added that soil amendment at the beginning of phase 2. And then we also had the doubled up treatment where we had soil and the soil amendment added. And then we monitored changes in crop response and soil properties in response to those 4 treatments. We have some preliminary data, but I don't have the final say on how all the statistics worked out. But I guess I would say that there's no replacement for soil.
Sure.
You can increase productivity by using other products, but there's really only soil is soil.
Yeah. Stay tuned, everybody, for more research on the way. That's awesome. I'm excited about that. That's lovely. So I have 3 questions left for you because I need to control my excitement about this project and wind us down here. So first question is, if people want to learn more about any of the things that we've talked about today, where can they go?
We do have at least one presentation recorded on this experiment, and that's available at our website. Will you be able to put this in the show notes?
Yes, I will.
Yeah. Okay. So if you go to the show notes, there'll be a couple links there. One is a presentation by me, and perhaps it'll be a repeat of a lot of what Abby and I talked about, but we'll also include some pictures of the site and the differences in crop productivity that we saw. So you could go there for a more complete picture. There's also, I want to point out that other people collaborated on this work. This wasn't just me. There were technical help and then scientific assistance, most especially by David Lobb from the University of Manitoba and Tom Schumacher, who's retired from South Dakota State University. David Lobb has done a lot of work in tillage erosion and also restoring productivity to eroded soils. And so there's a link to a presentation by Dr. Lobb in the show notes as well.
Perfect. So then if people want to take the next step and get involved, that could be as researchers or farmers who want to give this a try, any kind of stuff like that, how can people get involved?
Well, they can contact me or Dr. Lobb. Also, just for general information about soil conservation, I would recommend the Soil and Water Conservation Society or the American Society of Agronomy, Crop Science Society of America, Soil Science Society of America. They have some good materials online and in print for soil processes and soil productivity.
Yeah, that's great advice. Thank you for the shout out to us. I appreciate it. We're doing our best. So then what is one fun fact that listeners wouldn't know about you if all they had was your research?
Well, I don't know if there's too many fun facts about me, but I enjoy gardening. And I grew up on a farm, but now I live in a housing development. And so I don't get to be intimately tied to the soil anymore, except on a very small scale through gardening. So I have gardens at home, and then my husband and I volunteer to tend a perennial garden at our church. And I just find it very relaxing and also, very inspiring, the resilience of a Zone 4 perennial.
Well, lovely. This has been a lovely conversation. I have so enjoyed our time together talking about this awesome research that can obviously have a huge impact on hugely eroded soils. So thank you so much for your time and for being on.
Thank you. It was a pleasure.
thank you for listening to Field Lab Earth. More information can be found in the description below. Thank you!